Previously, we learned about the flexvpn and ikev version 2. Today is a day of demonstration. I'm going to demonstrate this. You can have a CSR or iOS also, if iOS supports. I have a router here which supports ikev version 2. Earlier, I tried in GNS3. It was not supporting, so I switched to EVE. First, I tried with CSR. It supported very well, but there was one. It was not a mistake. Just I corrected few things, but that was not a mistake. Again, I'm telling you how I know that, because when I copy the same configuration of CSR and put it into this iOS router 4 and 5, I had the same debug problem, same error in the debug. So it is not because of the router. It was some bug, I can say. Let me tell you what really happened. Yesterday we configured this ikev version to site-to-site VPN. And when I was troubleshooting, it was saying authentication failure. The debug was showing authentication failure. The debug was saying that I did not receive the password from the other site. Actually speaking, we had a password like P1, R1 pass or something like that, S1 pass, something like that. When I changed the password, it started working. Nothing I did other than that. You see, here if you see, show run, section crypto, YPT. I only changed the password and it worked very well. I changed the password, set to Cisco 123. The host name is locally significant, it can be anything. Local identity, this was one mistake I did, yes. I gave 200 address here. This is local actually. This is for peering. That was one mistake I remember, which I was having. I gave 200 address in identity address and I failed to give this command. So today, to avoid all this confusion, what I'm going to do is I'm going to remove all this crypto thing. I'm going to do it from the beginning again. So that it will be one video, all ikev version 2 and flexvpn and dvti svti all in one video I'm planning to give you. Now you see on this router I have removed all the crypto. So show run section crypto. I don't want to see anything as an output now, which means we are ready to start. Okay, transform set need to be removed. I'll remove. So there is no crypto commands, anything configured. So no IKE running now. So first, before I begin, I want to verify whether I'm able to reach the remote site. This viOS 5 is the remote site. For making it more realistic, I'm going to draw a circle. This is a site, and this is another site. Right, so site 1 in the left and site 2 on the right. You see, even the host name I have given as site 1 and site 2. Alright, so here I would like to ping 200.22.0.2. I'm able to ping. This is what we need for starting our lab. Let me write down the steps for you. so that it will be easy for you. In IKE version 1, we used to have a ISA KMP policy. Whereas in IKE version 2, we have a proposal. IKE v2 proposal. This is the subset of this. If this is step 1 in IKE version 1, this is 1.a. Means this is what we called as phase 1. In phase 1, we have ISA KMP policy, we have ISA KMP authentication. This is what we called as phase 1. This is what step 1. Step 2, we used to have transform set, IPsec transform set. Here, before you go to step 2, which is phase 2, we have 4 steps. First step is proposal. 1.b in subset of this one is IKE version 2 policy, in which you will be calling this proposal. Now this authentication is of 2 parts. 1.c, you need to create a keyring. IKE version 2 keyring, in which you will say the host name, the peer ID, and the local password, the remote password, and so on. And then IKE profile. Sorry, 1.d. IKE version 2 profile, under which you will be calling this keyring. So this is what the difference between version 1 and version 2 in configuration perspective. In concept wise, we saw instead of creating many policies to have different combinations of phase 1 parameter, we just have one proposal with all combinations in it. That's what we saw in the previous class. More detail, you can refer to the previous class video. Now, phase 2, as usual, IPsec transform set, and then ACL to define the traffic which will be encrypted and decrypted. Same here also. And then cryptomap. Even here cryptomap. And then assign it on the interface. Here also interface is assigned with cryptomap. That's it. These are the 5 steps in configuring VPN. Routing is correct. That is last. So these are the 5 steps in configuring a VPN. If it is version 1, phase 1 is simple, but if you have different combinations of phase 1 parameters with the different sites, then it becomes more complicated. To avoid the complexity, we have a proposal approach in IKE version 2. Now, in our lab, I already have IKE version 2 enabled on site 2, which is on the right. I need to just simply configure on one side to form VPN. The reason is it's going to be similar configuration. That's why I'm not recording the configuration of site 2. I'll show you those configurations which is already there in site 2 afterwards. Yeah. Our ultimate goal is whenever I ping from the LAN networks like 10.1 to 10.2 on the remote LAN and vice versa, my traffic need to get encrypted and decrypted when it comes. This is the idea. Right. I'm not going to show you the configuration on site 2. Site 2 configuration is already there. And I'm not going to do it on the command line also. I'm going to do it in a notepad. This is how it is. Crypto IKE version 2 proposal. Give any name. I'm going to say proposal propo 1. Now encryption, better we do it in the command line. The reason is Rashid was absent in the previous class, so let me show. Okay, so this is the proposal, and now we need to set an encryption algorithm. You see, encryption algorithm, you have lots of options. I can say I want 3 days. I can say I want also AES this one. Sorry, AES this one. I can say I want days. I can have many options, many combinations in one proposal, which is not possible in version 1 IKE. See, this is the big difference. And likewise, for hashing, there is no concept called hashing here. It is only integrity. Integrity, I can have combinations of many of this. Like I can say I want SHA-1. I also want to have MD5. So that some of my sites may have MD5, some of my sites may have SHA. I don't need to create different policy. I can have just one proposal which can associate with all sites with MD5 and SHA. Separate. Some may be having MD5, some may be having SHA. Still, I can associate with one proposal. Next. Encryption is over, integrity is over, group. Group, I can have, I can say 2, 5. What's the next small number? 2 and 5. I don't want to make more process. Enough. Now, these are the basic stuffs we need for a proposal: encryption, integrity, and group. Next is we need to call this proposal under policy. That's important. Crypto IKE version 2 policy. I'll say my underscore policy 1, and I'm going to call the proposal which I created above. The proposal name that I gave is propo 1. Yeah. So if you put question mark, you will not have much options. You have proposal, and then you call this boom, finish. So now when I take you, these two things are over. Proposal is written, policy is created, under which proposal is called. Next, key ring which will be used for authenticating the neighbor. The advantage of ikev version 2 is you can have both certificate as well as the pre-shared key to authenticate at the same time. Meaning for encryption you may use pre-shared key, for decryption you may use certificate because the other side is using certificate to encrypt, so you need to use certificate to decrypt. And when you encrypt with PSK, pre-shared key, the other side will be decrypting with PSK. For more information, you need to refer to the previous class video. Now, we need to create a keychain, keyring, crypto, IKE version 2, keyring. I'll say my underscore key. And the peer. The peer is just an ID to identify the remote peer. It need not to be the exact host name that you gave on the remote site. It can be anything. So I'm going to say VIOS5. Actually, there I have given host name as site2. Okay. Next. Here you need to use the command address first. Address. Who is your peer? See, if you don't know what address, the address is talking about the peer address, not your local address. To define local address, which is an optional one, you can use the identity command. So say address 200.22.0.2. The next is optionally you can say identity. Say identity, if you don't know why I need identity, it is for local. What will be your source address while negotiating? It's like, update source loopback 0 and BGP. Identity, I want to use the address which is 100.11.0.1, my own. Again, I'm telling you this line is optional. Next. The pre-shared key that you want to use for authentication. See, pre-shared key, you have both local pre-shared key, remote pre-shared key. If you are planning to use different passwords, if site1 is using ABCD as password, if site2 is using 123 as password, then you need to say local and remote. Say for example, pre-shared key local. Locally, I'm using the password Cisco123, meaning I'm going to encrypt my traffic with Cisco123. Pre-shared key remote, whatever that router will encrypt, whatever that router will use to encrypt. In my case, that router is doing both local and remote, means encryption and decryption with the same password. So I'm doing the same password, but I'm telling you, in ikev version 2, you have an option where you can have different password for you to encrypt and different password for the remote side to encrypt. If the remote side encrypts, you will use that to decrypt. So you need to use the remote side password here. Say for example, on the remote side it is Juniper123. In the remote side, local password is Juniper123. So that becomes a remote here. Your local will become a remote for him. Okay. So if you are planning to use the same password for both local and remote, you no need to say local and remote. You can simply say pre-shared key and then the password Cisco123. But anyway, I have given local and remote, it's okay. Next. These are the main things which is necessary for the keychain. Now we need to call this keychain under a profile. That is what going to finish your phase 1 configuration. Crypto IKE version 2 profile and give a name profile. I'm going to say my underscore profile. Right here, very clearly it says you need to match two things. One is local and remote authentication methods. What are the methods of authenticating? I'm going to use authentication local is using pre-shared key, authentication remote using pre-shared key. I told you, if you want one side with certificate, you can do so. But in our case, we are using pre-shared key. Secondly, you need to match with the identity. See, you don't need to remember the command. Very nicely, they show you hint here. Match identity. What is the IP address of the remote guy? Is 200.22.0.2. Yeah. Match identity, the address of the remote. I need to type address. See, not only address, you can have a domain name, you can have an email address, something like that. If it is able to resolve it, you can use it. All right, these are the main things. Second, very important thing which they have failed to mention in the list is the key that you need to call for authentication. The key that we created here on the above is named as I think my key ring or something I gave. Yeah, my key. This is what I need to call under the profile. Keyring local. What's this? So you see what happens. Please understand, I'm trying to explain you the logic. This guy is coming from remote. When he comes, it will check with the keyring. It will go to the keyring and it will check whether that site 2's informations can be decrypted with this. Yes, that means authentication is successful. That's how the phase 1 key sharing, key IDs or authentication happens. That's all the phase 1 configuration. It's over. So you see, keyring. In keyring, we provided the informations like address of the remote guy and the pre-shared keys or the certificate. And in the profile, we said what method I'm going to use for authentication and what will be the keyring. Now comes the phase 2 as usual. Phase 2 is crypto IPsec transform set. T-set, as usual, this is the name we are used to. T-set. So you can have different combination ESP, AES for encryption, ESP, MD5, HMAC for hashing. And now the default mode is tunnel mode, you don't need to specify. We need an access list. We need to write an access list. I think I already have that access list. Do show run section IP, not IP, access list. You see the access list is already there. I need to use it. If not, you need to create one. Any traffic going from this LAN 10.1, which is on the left, going to 10.2 is what we are planning to send through the VPN. Encrypt and decrypt. So access list is ready. Access list is identified the name 101, which means you have come to the end of the story. What is that? What is the end of the story? Crypto map. Crypto map, CMAP, any number, IPsec, ISAKMP, match address 101, and then set transform set T-set. Here, after that, we need to call the profile. Transform set is done. T set, correct, and you need to call the profile. In the profile, what do you have? Authentication method and the keychain to be checked. That's it. So, okay, set peer also is left. Set peer. Who is your peer? Very important. 200.22.0.2. And then we are going to say match. No, not match. Set profile. Set IKE version 2 profile. IKE version 2 profile is just copied and I closed it. Profile is my profile. Then that's all. I need to apply this to the interface. Interface G0/0. Apply this crypto map CMap. That is it. Finish. ISAKMB is on. Now routing need to be done. See, I have not done any static route on either side. Show IP route. You don't see any static route. So when you try pinging to 10.2 network, the routing table will say I don't know the route. So VPN will not work. So I'm simply saying IP route. Anything that starts with 10.2, send it out via G0/0. See, router in the middle, the router in the middle has got no idea about 10 network. So don't worry, only when VPN works, this ping will happen. Otherwise, it won't ping because the middle guy don't know the IP. When VPN works, what does it mean? Your original identity will be encrypted. Only the tunnel source will become the source, which is routable in the internet. Now, I'm going to do this similar configuration on 5. Just show IP route. Even here, there is no root. So I'm going to say 10.1. All right. Now, final move. Let's verify by typing this command, show crypto IKE version 2 SA. Show crypto IKE version 2 SA. You will not find anything unless you send some traffic via G00. So let us send some traffic. Ping 10.2.1.1, which is a loopback of site 2, with a source of 10.1.1.1, which is loopback 0 of site 1. 1 or 2 packets, see, wow, it's working fine. First packet lost because it took some time for the VPN to come up. You see, look at this. You got a VPN. See, same command which I was trying earlier. Earlier it was not showing any output. Now it says the VPN is ready to use, and VPN is up and now functioning, and it was using UDP 500. UDP means ESP, and this is the combination in which the tunnel was built. Encryption, we gave 3 protocols. It used the first protocol. First protocol was matching with the remote site, and SHA was the integrity, and group was Diffie-Hellman. It was pre-shared key that was used for authentication and verification done. And it's automatically, yes. Hashing we did not give it as default. And lifetime is one full day, 24 hours. It's active for last 9 seconds. It is active for last 74 seconds. The VPN is up for this many seconds. Let us also verify the other side on R5. Show crypto IKE version 2 SA. You can see the similar thing. It is forming tunnel with a remote called 101101. Local is this. And now let's see how many packets gets encrypted and decrypted. I'm going to ping repeating for 200 or 100 times. As it is pinging, I'll go to our remote site, show crypto IPsec essay, which is phase 2. As of now, 104 packets. Yes, first time when we pinged, out of 5, only 4 went through. And now 100 packets. So this is what IKE version 2 example configuration. You see, for transforms, this is the protocol we defined for hashing and for encryption. This is what we used for encrypting and decrypting the traffic. It was UDP 500 that is used. So you will see here 500 port number will appear. You can have even another client here with the same proposal with different combinations. That's the beauty of IKE version 2. Now what we are going to do next is we are going to see how to create a tunnel interface so that we can have SVTI, and DVTI. This is Cisco's idea, so it is called as flexvpn. We will be doing this flexvpn with the DMVPN also later. Our focus is today on this site-to-site, which we have already covered, and next we are going to do SVTI, and then followed by DVTI. SVTI stands for Static Virtual Tunnel Interface, where we'll be using a tunnel interface with a tunnel IP address, and we will have a LAN extended from site 1 to site 2. LAN extension, that is what tunnel interface, VTI, Virtual Tunnel Interface. So for tunneling, I would like to take a network, a private network, like tunnel 1 IP address. I would like to give 192.168.0.1 on this side. On this side, I'm going to give 2. Anything you like. I just want to give 2 for site 2. The reason why we need to use tunnel interfaces, you can negotiate using IPsec. You don't need to use crypto map. You don't need to put it on the physical interface. You can have a separate interface, a dedicated interface called the tunnel interface, where you can put those tunnel protection thing. So whoever goes inside the tunnel will be encrypted. Whatever the traffic that goes through the tunnel will be encrypted and decrypted. So you don't need to write access list also. So these are all big advantage. You don't need to write access list. You don't need to create crypto map. You don't need to put them in the physical interface where you already have a lot of complicated things in the physical interface like OSPF or MPLS or QoS. A lot. You don't need to mix with security. You can have a hygienic tunnel interface only for security. Though tunnel interface is going to use the physical interface, it has got separate encapsulation. So that's the idea. Let us do now tunneling. We call this as SVTI. And we are not going to use GRE. Don't think we are going to use GRE. No, we are not going to use GRE. We are going to use IPsec. So SVTI in action. Right. So what I'll do is I'll go and remove those ACLs and crypto maps on both the routers on sites. I'm in site 2. Show run crypto crypt section crypto here YPTO. So I'm not going to remove this phase 1 phase 2 configuration. I just do some slight configuration changes to phase 2. You see these things I still need it. I'm not going to remove them. I'll keep everything same up to here. Alright. The difference is here. This is not needed. Interface G00, no crypto map. I remove the crypto map. And then no crypto map configuration needed. And then there is no access list needed. Do show run section access list. No access list 101. That will remove the entire line. You don't need to paste the entire line. Right, so now there won't be any VPN. VPN is broken already. There is no VPN anymore. Show crypto IKESA. Clear crypto IKESA. Now there is no more deleted. You see, it is deleted. Delete. It will be removed after a few minutes. Oh, even previously it was showing deleted before I cleared it because I removed the configuration. Good. So now let's try pinging. I don't think now it will ping because the other side is deleted. Likewise, I need to remove even from this router, but I started pinging 100 times. That's very bad. It will take a long time to. It is okay. Meanwhile, we'll go to the site 2 and finish the tunnel configuration. On site 2, interface. Okay, I also want to remove the static route that we gave, which is no more needed. The static route is no more needed. See, what are all advantages? You don't need this static route. Instead, you need to write another static route facing towards the tunnel 0 interface. So we are not mixing the security traffic and the normal traffic. Normal traffic exits via G00. The security traffic will go through G00 but using tunnel 0 or tunnel 1 interface. Only when tunnel is established, the static route will be coming. Alright, SVTI, static virtual tunnel interface. Why it is called static virtual tunnel interface? Because you got the site addresses statically configured, not by DHCP. And using that address, you're going to negotiate a VPN. That's why it is SVTI. Next, we will do dvti, where IP addresses will be assigned using DHCP. Okay, anyway, now let's focus only on SVTI. What is needed for SVTI? You need the same configuration which you had for site-to-site using crypto map up to transform set. Do show run section crypto. You still have them. We did not remove them. You see, you have phase 1 up to here, and then yeah, up to here is phase 1. up to here is phase 1. We did not do any changes, and this is phase 2. Yeah, it's still the same. We don't have crypto map. We don't have access list. We are going to create interface tunnel 1 or 0. 1, I will use 1 because I named it as 1 in the board. Tunnel went down because there is no tunnel protocol mentioned. Let me say I want tunnel mode as IP sec IPv4. It's not GRE. Next is, for the tunnel I need to provide an IP address. What is the address? We plan to use 192.168.0.2. This is the ID for the virtual connection that will come in between these two routes. This type of virtual connection is not in CryptoMap. It was using the physical interface, so there was no need for a virtual interface. We were binding the CryptoMap on the physical interface, whereas this is a separate interface. It needs an IP. Done. And then what interface the tunnel will use, or what IP address the tunnel will source the traffic. It will source the traffic with the VPN interface 100. Sorry, I'm in router 2, so it is 200.22.0.2. Or you can also say the interface name G0/0. You wish you can give the IP address on the WAN interface or the name. Tunnel destination, you know very well the destination. That's why it is called as SVTI. You know the destination. Who is the tunnel destination? 100.11.0.1 is the tunnel destination. So we have the tunnel IP, we have the tunnel source, we have the tunnel destination, we have the tunnel mode. What only thing left is the tunnel protection. That's the only thing that we have not configured. Tunnel protection. For that, I need to know the name of the profile. This is the name of the profile. No, this is ikev profile. I need to create another profile, IPsec profile. Okay, I need to create an IPsec profile. Crypto IPsec profile. Okay, let me go to the notepad and then explain you. Then I'll come back. See, earlier we were doing ACL, which is no more needed. CryptoMap, you're not applying to the physical. Instead, we are going to have a virtual interface. So I need to call this transform set under the profile. Plus this phase 1 profile. Further, I need to create phase 2 profile. We call it as IPsec profile, in which you will call the transform set and the ikev version 2 profile. Two things. All right. That is what going to become the protection for the tunnel. So IPsec profile, I'll say IPsec -prof, and then I have to call transform set. I think I give T set, and then set ikev version 2 profile, and I'll call the name there. the profile that has got the authentication methods, this one. This is what has got those authentication method is local, is pre-shared key, all the stuff, right? So, boom. Now I need to call this as a tunnel protection to the tunnel interface. So, what is the ikev version? Oh, sorry, IPsec profile name? This one. If I know this one, that is enough for the tunnel interface. Interface tunnel 0, I say tunnel protection using IPsec IPsec profile. This is the name. Boom. That's it. You'll see now IK coming up. Let me show you once what we have configured. Show run interface tunnel 0. Sorry, tunnel 1. Oh, come on. I have put it in the wrong interface. It's not tunnel 0. I should have put it in tunnel 1. That's why it was not coming. Okay, no problem. Interface tunnel 0. I need to say no. Interface tunnel 1. Tunnel production is this. Okay, done. See, ISAKMP is on, means phase 1 is on. What next is I want to show you all that I have configured. For that, I'll type first show run crypto. Show run section crypto. And here, this is what we just created. We call the transform set, we call the profile. The profile has got a keyring. The profile knows with whom it needs to negotiate. The profile knows what authentication method. So we call that phase 1 profile under the phase 2 profile and the transform set. We applied this on the tunnel interface. Show run interface tunnel 1. This is what the tunnel interface IP address, tunnel source, tunnel destination, tunnel mode, tunnel protection. Yep, there's nothing more needed. Show interface tunnel 1. You see, this is what the tunnel interface we have. This is the IP address we gave. This is the bandwidth. It is using the physical interface actually. Encapsulation is tunnel. It's down because the other side is not up. And next is tunnel destination. You see, we gave source and destination. So it needs to, whom it needs to negotiate. And then that's it as of now. See, the tunnel protocol is IPsec IP. Now we need to do similar configuration on site 1. Here is site 1. Show crypto IKE version 2 SA, nothing. Let's create tunnel. Before that, I need to remove a lot of things. Do show run section crypto. I want to remove the crypto map from the interface. Interface G00, no crypto map. And then no this thing. Right, and also no access list 101. Then now it's time for us to start the IPsec profile configuration. Crypto IPsec profile my underscore IPsec prof set transform set tset set IKE version 2 profile. I didn't. I do have, no. I already had, no. So I'm going to use the same profile. IKE version 2 profile name is this. You can also see on the top this is the actual profile. All right. Boom. Now what is next is I need to use this as a protecting profile for my tunnel. So interface tunnel 0, sorry, tunnel 1. IP address is 192.168.0.1. Tunnel mode is IP Sec IPv4. Tunnel source is 100.11.0.1, which is my own exit interface. Tunnel destination is 200. This is why we call this svti. Tunnel protection is using IPsec profile, this one. That's it. You see the tunnel change status has come to up because the other side is available. Now let us go back to, see here also it is showing up on site 2. Now let us check the not running configuration. Show interface tunnel 0. Now we can see that it is up. The tunnel is up. There's one member and things are looking good. What is next is for the traffic to use the tunnel, I need to push the traffic through the tunnel. So I'm going to say IP route. You can also enable some routing protocol, but I wish to use a static route. IP route. If you want to go to 10.1.00 network, use tunnel 1 interface. That's it. Likewise, on the other side, on site 1 side, if you want to go to 10.2, use tunnel 1. You see, the middle router has got no idea about these 10 networks. I'll show you. Show IP route. It has got no idea about 10 network nor about 192 network, right? Fine. Let us now go to site 1 router and try pinging site 2's LAN. First I'll ping with 4 packets or 5 packets, then I'll ping 100 packets. Right now, show crypto IKE version 2 SA. It's already ready. It's already ready because the protocol is IPsec IP negotiated already. So now if you ping, the ping should happen. So all the 100 packets are successful. I can go and show you on the other side also. Show crypto IPsec SA. You can, show crypto. Sorry, not on this router. I need to go to the other side. This is intermediate router, INT. Site 2. Show crypto IPsec SA. You can see 100 encryption and decryption. I'll ping another 100 and you will see now that side 200 encryption and decryption. So this is SVTI. What is coming next is dvti. Are you comfortable up to here? Wonderful. Now the idea behind dvti is we have a IP address which keeps changing on one of the side, not on both sides. Again, I'm telling you, on one of the side. For example, here we don't know what IP address will be here. We don't know any. We have no idea what address will be there. We don't have any idea. That keeps changing. Because it's receiving IPs through DHCP. So what we do is to make it more realistic, let's go and configure DHCP on this router. We'll make this as a DHCP server. IP DHCP port ABC network 200.20.0.0 255.255.0.0. That's all actually I need for this. I'll ask to exclude one address, IP DHCP exclude address 200.20.0. Sorry, 2022 no 22.0.10 because this address is there on the physical interface. So let me go and change the DHCP network. I made a mistake. It is not 20, it is 22. So from this subnet, one address will be dynamically assigned to the client whoever asks. I'll go to the client and I'll tell the client that I'm not willing to give you IP address. This is the client. Interface G0/0 IP DHCP. Okay, wait. No IP address. I cancel the IP address. IP address is through DHCP. Done. Now I have said you need to get IP address from DHCP, and that's why OSPF. Okay, now it has come up, which means it has got an IP address. See, DHCP has assigned an address 200.2.0.1. Why is this mask? Oh, again, I made a mistake. It should be 32 mask. I'll go and change the mistake that I did. Okay, so I need to clear the pool first. Clear IP DHCP binding star. And now I'll go and configure a new mask. But okay, yep. I need to change it. I do remember I configured this first. This is what we configured earlier. I need to remove this. And now I need to provide the new one. Okay. Now what I'll do is I'll go to R5 means site 2 and say interface G00 shut down so that it'll forget the old address. And then I'll say no shut so that it will get a new address with new mask. See, you got a new mask and you got an address called 1. Now show IP interface brief. See, you got an IP address. Assume that this address you don't know, or this address will be keep on changing. You cannot rely on this address. You cannot rely on this address. This keeps changing. What should we do? See, on router 4, please pay attention. On router 5, there is no change. See, in router 5 only it is DHCP, okay? But for VPN, there is no change. On router 5, in site 2, there is no change because site 2 knows the destination. This destination is static here. Site 2 knows the destination. On Site 2 router, show run interface tunnel 1. This is perfect because you know the destination very well. But who don't know the destination? It is Site 1 don't know the destination. So that is where you need to create dvti. So we have dvti. What does that mean? I want an address. I want an address, meaning Site 1 needs an address to identify Site 2. Before that, Site 1 need to authenticate Site 2. Listen, this is very important. Site 1 needs an address to form a tunnel. Site 1 address is this one. I remove no interface tunnel 1. I remove it. Okay, there is no more VPN. I removed the tunnel interface. Alright, so now if you see show crypto IKE version 2 SA, nothing. It is deleted. It is deleted. You see, I want to form a tunnel with our Site 2, but I don't know the address of Site 2. For that, I need to learn the address. How and where. When someone comes and negotiates, I learn it. When someone comes with the right password, I'll know he is the remote site. So, you see, we have removed the tunnel interface. Show run section crypto. I need to do a lot of alterations. Please pay attention to these alterations. This one we don't know. This one we don't know, right? Let me go and change it. I don't know with whom I need to associate. Address. Okay, peer. The peer is named as, can be any name. I give this name. No address, okay? I cancel the address because I don't know the address of the peer. And I say address, the peer can be anyone. All right? Do show run now section crypto. Likewise, I need to remove on the profile also and put 000. You see? Here on the key I said I don't know who is my remote person. Likewise on the profile also I'll say no boom, and then I'll say match identity remote address can be any. That's it. Now let us see the overall crypto so far that we have. Show run section crypto. You see here, there is no information about the remote site anywhere because we don't know. Now, when the authentication is successful, see, it can be anyone, no? I said anyone can come. If anyone comes with the password which is said here, then he is genuine. That genuine guy is the peer. For learning this genuine guy as a remote peer, as a tunnel destination, I need to have a template. Instead of tunnel interface, we usually say tunnel one instead of tunnel interface. I say tunnel interface need to be dynamically created. I just will give you template. I'll create a template, maybe one, type tunnel. In this, I'll put tunnel source is G00, my own, but I cannot put destination, that need to be learned dynamically. Tunnel mode IPsec. Please understand, whatever you used to put in tunnel interface, you need to put it in the template, so that once the address of the destination is learned, these things can be used from the template for tunneling. Tunnel protection using IPsec profile. What's the profile name? Please understand, whatever we used to put under the tunnel interface, we are putting under the template. Let me show you what we used to put in the tunnel interface. You see, inside the tunnel interface, we used to put the source, which you see here, and then we used to put the mode, which is here. We used to put protection, which is here. This one is what we cannot give, it needs to be learned dynamically. Secondly, this one also you cannot give directly on the template because it's a template. What you can do is you can create an interface called loopback anything. Listen, why I'm creating loopback? Because I cannot assign an IP address to the template. So I'm saying loopback maybe 11, IP address 192.168.0.1. This is what I want to give it to the tunnel. And I'll say interface template 1, virtual template 1, IP unnumbered loopback 11. You know what is this meaning? When the original tunnel is getting created, it needs to take the IP address that is there in the loopback 11 as the tunnel interface and all the rest that I have in the template. Listen, let me show you. Why it takes so long? Show interface tunnel, sorry, show interface virtual template 1. You see, this virtual template is right now down and it will be using the address from the loopback when the tunnel comes up. So far, no tunnel destination is discovered. Source is this. Protocol is this. Protection is using this profile. Okay. Now, this interface will be always down only. Show IP interface brief. Look at this. It is always down. And this is the address of the tunnel. Now, what we need next is testing. Testing. I cannot test because I have a static route pointing towards the tunnel. So I am going to go with the dynamic routing protocol. I'll remove the static route which we gave long back. No IP route 10.2.1.1. So 10.2.0.0 using tunnel 1 interface. Did I say this? Yeah, I think that is already removed because we don't have tunnel interface. Show run interface, sorry, show IP route. There is a static route. Okay, it is pointing towards G. Let me remove this. What am I doing? G0. Alright, I remove the static route. There is no static route anywhere on site 1. I'm going to depend on a routing protocol because we don't have any interface so far ready to form tunnel. That will be dynamically done. Okay, so let me see. The negotiation should have, if site 2 would have initiated, by this time I should see tunnel. Show crypto ikev2. No tunnel so far. Yeah. So let's now run maybe EIGRP. Router EIGRP10. The networks are 192. This is tunnel network 192.168.0.0 and network is 10.1.0.0. Mask is 255.0.0. Yep. Likewise, I'll go to site 2, remove the static routes and put EIGRP. It's internet. I don't want internet. Router 5, yes. Show IP route. Here I have static route. No static routes. Good. Now what I'll do is I'll go and create a routing protocol. Router EIGRP10. Networks are 10.2.00, 255.255.00. The network is 192.168.0.0. Right, we got EIGRP on either side. Show IP interface brief. The tunnel 1 interface which we have already is still down. It is still down because the negotiation has not happened. I'm going to initiate some traffic saying 10.1.2.1 with the source 10.2.2.1 and not that. Let me see whether everything is in place. Show run interface tunnel 0 to tunnel 1. Okay, tunnel 1 is looking, configuration is looking good. Show run interface virtual template 1. IP unnumbered gig. Okay, source destination we cannot give. protection, blah blah. I think I need to just shuffle the interface. Interface virtual template. Shutdown, and then I need to say no shutdown. No shutdown. You see virtual template changed it to up because I say no shutdown, but I'm still not getting what I want. Interface, let me say here interface tunnel 1, shutdown, and no shutdown. Oh, you know why? Good. Thank you. It didn't come. See, there's a logic. What? We need to tell the profile that negotiation will come dynamically. We need to tell to this IPsec profile. That is the only missing piece. You see, show run section crypto. We were we were telling that if someone is coming and negotiating, if the authentication is good, you see, we said here use this profile, and we said in this profile we don't know who the other side is, but if he comes with the proper key, he is the right guy. But we did not say what interface this profile will use. We don't have a tunnel interface, right? So we need to say I have given you a template. That is what you're supposed to use. How do we say that? We are inside this profile, IPsec. Sorry, not in this. In phase 1 profile. Crypto IKE version 2 profile. Yeah, that's the profile. What's the profile name we gave for IKE version 2? Yeah, this is where we need to say, okay? So crypto IKE version 2 profile, you will have an option there. Put question mark. And look at this. This is it. We created a virtual template, right? And we are saying use the virtual template. Means whatever we have mentioned in the virtual template, it will copy to the interface. The virtual interface that it will create. It will create a virtual interface called virtual access, to which it will copy. So this is the only missing piece. Now it should work. All right. I'm waiting for that. Show run interface brief. You see, there is a new interface called virtual access 1. Change state to up has come. You see, EIGRP neighbor has come. This is the best proof that neighbor is already there. Tunnel is already there. See, there is no EIGRP in the middle router. You all know that. All right. Now, you see, show, not show run, show IP interface brief. You see, this is the new interface that got dynamically created. It is to this interface. Everything from the template is copied. I want to show you this. See, this is not the interface that we created. But you see, show interface, boom. You can see this interface protocol app. And look at this. The destination is dynamically learned. And this is the source. How the destination is learned? Who is the source? It is the virtual template. All right. So now you can see the profile is used. Everything is as usual. As a result, if you check the routing table, you will see the route via the virtual access to reach the remote site. Now, if I ping 10.2.1.1 with the source loopback 0 of mine, I'm able to ping show crypto IKE version 2 SA. You see, it is ready. It's using show crypto IKE, IPsec SA. You can see 31 packets, including EIGRP. No, it's encrypted and decrypted. Repeat for 100 times, and I should see at least 132 packets of 134 packets. All right, so the only missing piece is which I was not doing in the early stages. This one, I need to go inside the phase 1 profile. I also did a mistake trying to bind it to phase 2 profile, but I didn't see an option called virtual template. Later, I realized that it should be done to the phase 1 template. That is where the source need to be learned. Means for this router, it's destination. The destination need to be learned, and then I gave this command called virtual template inside that. Yeah, let's see that. Show run section crypto. You see, this is the line that I added. Why I need to add in this? Because this is where you need to know the remote address. Yeah, if it is learned here, it will be also learned here, and everything will go good. Yeah, so it needs to be done on the phase 1 profile, not to the phase 2 profile. You will not have an option called virtual template in phase 2 profile. First, phase 1 should be authenticated, right? That makes sense actually. Phase 1 need to be authenticated, then only phase 2 comes. So I should have not tried on the phase 2 profile. That was my mistake. Phase 1 is the place where the remote site need to be identified with authentication. Hope this makes sense. Do you have any question? Right. Hope you enjoyed this IK version 2 and Cisco's dvti called flexvpn. We'll be doing this flexvpn with the DMVPN in our next class. I'll also give a very good brush up of DMVPN, and then followed by this FlexVPN in DMVPN.